Hi, Form 3 girls. We will continue our physics online learning, so please be ready for the lesson. Take out your physics exercise and turn to chapter 3, page 4, and bring your calculator as well. In this section, we are going to learn an interesting phenomenon called free falling. That means objects fall freely under gravity. And before we have the experimental demonstration, let us have a watch of a famous science story.
Aristotle. Born in 384 BC in ancient Greece, he was a famous philosopher. He also made great contributions to many other fields, such as ethics, politics, and science. One of Aristotle's most famous contributions to science is actually based upon a false claim. For years, Aristotle preached that heavy objects fall faster than lighter objects, stating that the speed at which something falls actually depends on its weight. He would explain it to anyone that would listen. His example was that an object 10 times heavier than another would have to fall 10 times faster. No one disagreed with Aristotle. Most people were comfortable with the idea of heavy objects falling faster because it's what they were used to seeing. For almost 2,000 years, Aristotle's rules for falling objects remained unchallenged until a new scientist attempted to prove him wrong.
Oh, you're probably wondering what I was doing. Well, that's none of your business. But what is your business is the Leaning Tower of Pisa, a building famous for its improper construction. When it was built in the 1100s, part of the foundation began to sink, which is why it now leans to one side. Another reason why this building is famous has to do with the dispute between Aristotle and our next scientist.
In the year 1589, an Italian scientist named Galileo attempted to prove Aristotle wrong. Galileo believed the only reason heavy objects fall faster is because air resistance slows down lighter objects, and that if air resistance could be reduced, they would both fall at the same speed. In order to prove his point, he gathered everyone in the city, climbed to the top of the Leaning Tower of Pisa, and explained that the only way to prove who was right for sure was to perform a scientific experiment. Galileo's experiment went like this. He stood at the top of the Leaning Tower and held out a cannonball and a wooden ball of the same size. The only difference between the two objects was their weight. Galileo explained that since they are the same size and shape, they would feel the same amount of air resistance as they fell. His conclusion was that they should hit the ground at the same time. So he leaned out over the edge, dropped both objects, and a little more than 3 seconds later, everyone in the city of Pisa saw the cannonball and the wooden ball land at the same time, proving once and for all that if there is no air resistance, all objects, no matter how heavy, will fall at the same rate.
So this is the end of this video. Okay, we can have a demonstration in physics lab if the class is resumed later. Here is the setup. We have a metal ball here and a magnet attached to the metal ball, and it is placed H meter above the ground. Later on we will release the ball. And you have to use a stopwatch to time the time taken for the ball to travel from the top of the journey to the ground. So let us start now. So initially, the initial speed of the ball is 0, and then it falls to the ground. And from the stopwatch, you can find out the time taken for the ball to travel for this whole journey. Is it okay? So how can you find out the acceleration or the acceleration due to gravity? Then you can make use of this formula, because you know you can find out the distance traveled by the ball, which is equal to h, and the initial speed of the ball, because it is released from rest, so it is 0. And then half, and a is equal to g. We use the symbol g to represent the acceleration due to the gravity, okay, and the time taken, which is recorded by your stopwatch. And then you move the numbers to one side and make g the subject of the equation. So g is equal to 2h, 2 times h, and then divided by t squared. Okay, if you can demonstrate this experiment in physics lab, then you have to measure the distance traveled by the ball and the time taken. Then you can find out the value, which should be equals to 9.81 meter per second square. No matter the ball is small or the ball is large, okay? According to Galileo speaking, all objects fall at the same rate. That means with the same acceleration during the fall. So it is the free falling motion. So please pay attention. For object falls under gravity, the acceleration is 9.81. It is not necessary for the question to give you this value. You should know this value you should find out this value by yourself. Is it okay? So let us have some demonstration about the classwork. Okay. Page 4, question 1 and 2. So for this one, okay, Susan released a cone from the second floor to the ground in school, or maybe just outside physics lab, the second floor, okay, to the ground in school. And the distance travel between the second floor and the playground is 10 meter. Okay, the distance is 10 meter. So you know the value of s. So you have to find out the time taken for the cone to reach the ground. Okay, it seems that you have you have not many known values. Okay, so can you find out the rest of them? You need 2 more. So look at the question again. Susan release a cone. Okay, if you release some object, it means that the initial velocity of the object is equal to 0, right? And because it falls under gravity, so the acceleration is 9.81 meter per second square. Okay, it will not be given to you if object falls under gravity. So you should know that its acceleration is 9.81 meter per second square. Is it okay? So you have S, U, A, and you have to find out the time taken for the journey. So which equation you will use? Right, the third equation. Okay, so you write down the equation in the first step, and then put the numbers into the equation. U is 0, so you can ignore this term. Equals to 10 equals to half, A is 9.81, and then T square, right? Then you multiply 2 to the left hand side, and on the right hand side you have 9.81 times T square. Is it okay? Then you divide 20 by 9.81, and then take the square root. I think you can find out the answer is equal to 1.43, and the unit is second. Okay, is it difficult? So from this question, the acceleration is not given to you. Then you have to find it out by yourself. Is it okay? And then question 2. Question 2, in a bungee jump, do you know what's meant by bungee jump? Okay, if you know, then maybe we have a look of what is meant by bungee jump.
Good grammar and spelling are important, but if you want to write essays that inspire,
so it is a bungee jump. Okay. Do you want to try? So maybe we stop here. So the player for the bungee jump in the first part of their journey, okay, when the cable or the string is loosened, then they experience a free falling, okay. So if you have chance, you can take have an experience of it. I according to my knowledge, okay, the closest place for the bungee jump is from Hong Kong is Macau, okay. You can try it by yourself if you have interest about that. If you are interested about that, okay. So in a bungee jump, Candy jumps from a cliff and falls freely, okay. Can you estimate her speed after 2 seconds? Okay, not many numbers in the equation, okay. So you have the time and you have to find out the speed, but you know the acceleration during the fall is 9.81 because Candy falls freely, right? And usually in the bungee jump, the initial speed of the player is 0. Then you have to find out the V, okay? Is it okay? So you have this number. This number is not explicitly given to you. So you know the acceleration and the initial speed. So which equation you will use to find out Candy's speed after 2 seconds? Yeah, this is the second equation. So you write down the equation in this form, or A equals to V minus U over T. Both are the same, okay? And then you put the numbers into the equation. 0 equals to 9.81 and the time is 2 seconds. Then you can find out the speed is 90.6 meter per second. Is it okay? So you can have this format, or you can write down A equals to V minus U and then divided by T. Both are correct. So we have the rest 2 equations, question 3 and question 4. I think you have confidence enough to try this question by yourself now. So please pause the video and then do them now. And after that, you can continue to watch my demonstration to check whether you got the correct method or correct answers or not. Okay, please pause the video. Okay, I suppose you have finished, okay, your working. Okay, look at this one. This one may be a little bit complicated, okay. A can of soft drink is dropped from the 2nd floor of a building, maybe outside physics lab again, okay. If each floor is 3.5 meter high, so what is the distance traveled by the can after 2 seconds? Okay, so from this equation, from this question, the soft can drop from rest. Okay, the initial speed of the can should be 0. You drop something, okay, not a flow downward. Okay, and if the time taken is 2 seconds and fall under gravity, so you know the acceleration should be 9.81 meter per second square, right? So can you find out the distance travel? That means you have to find out the value of s. So which equation you should use? Yeah, I will use the third equation. Okay, s equals to ut plus half at square, right? And for the first term on the right hand side, U is 0, so you can ignore this one. A is 9.81 and T is 2 seconds. Okay, so then I think you can find out this answer, 19.6 meter. But the answer in your exercise book is not this one. Do you know the reason why? Yeah, this value is greater than 7 meter, which is impossible. Do you know the reason why? Because you stand on the second floor, and each floor is 3.5 meter. So the height of the second floor from the ground should be 7 meter. How can an object travel by a distance greater than the 7 meter? It is impossible. Do you know the reason why? Because the can has already landed on the ground before second, right? So what should be the distance travel? If this value is less than 7, then this one will be the answer. But if this value is greater than 7, then the answer should be 7 meter only, because the object lands on the ground before the time, right? Okay, so this question is a bit tricky. Okay, you should pay attention about the answers that you have got. Okay, if this value is less than 7, then it is okay. But if this one is greater than 7, then it is impossible. Is it okay? Okay, the last one. A piece of stone is released from rest. Okay, so maybe look at this diagram. Okay, released from rest from the rooftop of a building. This is the rooftop of a tall building. Okay, then it falls vertically under gravity and takes 6.6 seconds to reach the ground. Okay, so look at the equation. You have released from rest. So the initial speed is 0. And the time taken is 6.6 seconds is for under gravity. So under gravity, the acceleration is 9.81 meter per second square. The time is 6.6. You have to know how tall is the building. That means the distance traveled by the stone. Okay, so you will use the third equation, right? So you put down the numbers. The first term can be ignored because the initial speed is 0, and A is 9.81, and the time taken is 6.6. Then the value is 214 meter. That means the ball released from the rooftop of a building, and if it takes 6.6 seconds to reach the ground, then the distance travel will be 214 meter. That means the height of the building is also 214 meter, right? And when it strikes on the ground, can you find out the speed of the stone when it hit the ground? Okay, then you have to find out the V, the velocity, the speed of the ball when it reached the ground. So you use this equation, V equals to U plus AT, or you can write down the format A equals to V minus U divided by T. Both are the same, okay? So the initial speed is 0, and the acceleration is 9.81, and the time taken is 6.6 seconds. So you can find out the speed of the ball when it hits the ground, which is equal to 64.7 meter per second. Is it okay? For the second part. And for the third part, if a bullet, there's a bullet, okay, is fired vertically upward with the speed calculated in B. That means if the bullet fired with a speed 64.7 meter per second vertically upward, okay, then can you find out the maximum height that the bullet can reach? If the stone released from rest, and when it strikes on the ground, its speed is 64.7. For the bullet with different mass, if it fires vertically upward with a speed 64.7, So how high can it reach? So I think everybody of you can guess. If you fly with this speed, then you can reach to the same height because it is the reverse of the motion of the stone. Okay, so the maximum height that the bullet can reach is 214 meter, which is the same as the answer in part A. Okay, so these are the questions we should be able to solve about the free falling motion. And there are some questions in assignment 3, okay, of the free falling. So please complete the assignment 3 on or before this Friday. And 3A and 3B girls, please email your completed assignment to Mr. Chen. And 3C and 3D girls, please email them to me. And then goodbye. Bye bye.